I'll start. Okay, so the session today is how to identify performance and stability issues using the magical powers of FusionReactor. This is a session. My name's David. I'm the CEO of Integral. So we're the folks that make FusionReactor and also Nerd Vision. So the agenda for today, I'm just going to talk briefly about how applications have changed and what those changes mean for monitoring. I'm then going to talk a little bit about how FusionReactor has responded to those changes. Then we're going to jump into the demo part. So we're going to look at how we can identify a bunch of common problems using some of the existing and some of the new features in FusionReactor. I'll take a bit of a closer look at our new logging capability, which we've just released in FusionReactor 9. And then at the end, I'll show you some of the new capabilities which we've got in FusionReactor Cloud, and give you a little bit of insight into what we're going to be doing in the future. And if anybody's got any questions, just post them on chat. I will endeavor to pick them up. Oh no, actually they'll come in the Q&A, so I'll see them separately in the questions area, so I can just address them either as I'm going through if I think it's relevant, or I'll pick them up at the end for sure. Okay, so let's start. Okay, so first things first, mission statement, and our mission has never really changed with FusionReactor. So the mission is basically to help developers get better insight and transparency into their applications. And the ultimate goal that we're trying to achieve is that we speed up the task of finding issues. And based on what our customers tell us, when they adopt and use FusionReactor, they can speed up that issue identification by up to 5 times faster. And hopefully you'll see that as we start going through the demo. So software development's changed and monitoring's changed with it. Basically through the migration to people using cloud platforms, or whether it's AWS or Azure or Google Compute, whatever it is, and the adoption of microservices, Kubernetes, Docker, so containerized environments, there's basically been a big shift, and monitoring has had to change in order to take advantage and to keep up with those changes. And what we generally talk about now in the monitoring or observability space is this concept of metrics, logs, and traces. And I'll come to that as well, going a little deeper in a moment. But there's also quite a shift moving towards AI operations and machine learning. So the future of monitoring really will go in this direction, and the future of monitoring really will go a lot in the direction of automation. So being able to automatically detect situations and alert you about various incidents going off. And I think the future, which probably isn't that far away, will be automatic analysis and automatic fix of situations. And I'll be able to demonstrate some of the stuff that we're doing in the area of machine learning a little bit later. So the challenge in all this is really to basically get a complete picture of your whole environment. So that's not just the actual application that you're running, but it's everything in and around the application. As I mentioned before, we've got these so-called these three pillars of observability, which is metrics, logs, and traces. And a big part of this is being able to show the sort of the end-to-end transaction scope. So if you like, being able to look at something that's executing and look at that, you know, within Cold Fusion, but then also beyond. So if you're calling out to other technologies, that you can basically see that transaction right across its lifespan. And this is something that we're able to do in FusionReactor. And as part of the changes that we've just made to FusionReactor 9, I'll be able to demonstrate that to you in a moment. So what we've done as in response to these changes, and what we've done as part of our FusionReactor 9 release, is basically to re-architect our whole platform. And we see this sort of as a unified observability platform for developers and DevOps. And we've essentially embraced open source software for this. So based on the CNCF, the Cloud Native Computing Foundation, we've built a platform based on Prometheus for metric capture, Loki for ingesting and analyzing logs, and using Tempo to capture trace information. We've also embraced something called OpenTelemetry, and OpenTelemetry opens up a lot of opportunities to monitor not just Java or Cold Fusion, but also other technologies like .NET, C++, Python, Node, and I'll be able to demonstrate that to you as well once we get into the interactive part of the presentation. So this is basically that this change in this architecture is opening up a lot of possibilities for us. So not just like I said, not just monitor a specific application, but to monitor an application together with all the infrastructure around it, to integrate with other components which are part of that infrastructure. So things like Kubernetes or AWS or nodes, so actual hardware components, networking components, and to tie all that together in sort of a single application that gives you visibility across your whole architecture. So before we sort of get into the demo part of the presentations, a quick word: developers don't have it easy, and this is sort of why we're here, really, because developers don't have it easy. And there was a recent survey by DZone where they said 32% of developers actually spend about 2.5 days to isolate production problems. And the majority of that time, so about 75% of that time, is actually identifying the what's called the mean time to know. So if you think, you know, out of your 2.5 days, the majority of the time is actually trying to understand what's going, you know, why something's broken. Usually, you know, pretty quick that something breaks. Once you've identified what that thing is, it's usually pretty quick to fix it. But the majority of time is actually trying to understand why. Why is it broken? Why is it performing poorly? And that's really where where FusionReactor sort of focuses in shortening that time. And another stat there is 94% of developers still use logs to identify errors in production. it'd be interesting to know whether that rings true with everybody who's on the call today. But certainly, whenever I'm at events and I talk to people who were, not always using FusionReactor, then very often they tell me that they just use logs. So I think logs are still an intrinsic piece of the puzzle when identifying issues. And as I mentioned earlier, one of the things that we've done with FusionReactor 9 is now to include ingesting of logs so that we can tie logs together with transactional data to basically join all the dots so that you get all the information that you need. Okay, so let's jump into the demo, identifying performance and stability issues. And some of the common problems that you're faced with is things like performance problems, memory problems, or debugging, so something went wrong. So with performance problems, you could have things like resource limitations, potentially due to socket issues, or you may have a caching problem. And we'll use the resource metrics and the profiling capability to help you pinpoint issues in those areas. Then we've got you may have some transaction that calls out to some service or some external database or some other system, and this is the time where you really need distributed tracing. So this is a new capability that we've introduced now, but I think you'll see once I demonstrate that what the power of that is. Then very often, probably about 65% of people that we talk to, their performance problems are related to database issues. And that could be, poorly written queries, or, that you're bringing too much data back, or potentially you've got some memory related issue with a database query. And I'll also demonstrate FusionReactor's capability to highlight those problems. Then there's memory issues, whether it's allocation of too much memory or you've maybe got a memory leak. We'll be looking at that. And finally, we'll take a look at the debugging capability. So this is maybe where you've got, you've experiencing an error like I don't know, a null pointer exception or something, or whether you're trying to investigate an issue. So you need to use the debugging capabilities to set breakpoints or set trace points in order to capture context of that problem so that you can address the issue faster. So without further ado, let me switch screens. Okay, so this is FusionReactor, and FusionReactor is a hybrid monitor. And what that means is FusionReactor's got an on-premise user interface, and it's also got a cloud user interface. So if I just go onto my servers here, so I've got 8 servers currently running, and what I was looking at here, if I click on my production server, so I've got a few different servers running. I've got a Tomcat server here, I've got a CF 2018, we've got a couple of Lucy servers running in the background. But you can see this screen here, which is showing various metrics. So you can see the heap, JDBC activity, thread state, memory, and this is in live mode now. This is equivalent to this screen. If I do a refresh, if I put this on sort of 1 second refresh, this is not as configurable here, but it's showing the same telemetry. So the point to put across is you've got, with Reactor being a hybrid, you can use it just as an on-premise only UI, or you can use it as on-premise and a cloud-based UI. So if you take the cloud license, then we'll push telemetry up to the cloud, and you can see if I change the time frame here to the last 30 minutes, it'll just update, and I've got access to that information. So let's start looking at some performance problems. So I'm going to go into my applications area here, and I've got a Cold Fusion store. And this Cold Fusion store is running on a couple of different servers that I've got here. And what I'm looking at now is my slowest transactions, and I can see that the slowest transaction here is this products.cfm page. And I can see from the response time, some of these were really very slow. This one up here was 54 seconds, but I've got some fast ones too. So let's sort of focus at these ones that were slower. And I can see I've got one that was actually through an error here, but I'm just going to focus on these ones that were very slow. And if I drill into that transaction, I can see that this one took 49.74 seconds. Now, if I look into the sub-transactions tab, actually, this isn't telling me that much. I can see I've got a select statement here, which just run for 1 millisecond, and I'm doing some CF-HTTP GET call here, but that also ran in 156 milliseconds. So, you know, what's going on here? I can see that my page seemed to run very quickly, but this whole thing ran for 59 seconds. And in order to determine what's going on here, we need to look at the profile. Now, FusionReactor, if you install it out of the box, anything that runs for longer than 3 seconds will be automatically profiled. And the profiler is basically analyzing each method which is being called within your transaction, and it's showing you the percentage of time and the amount of physical time which is being used in that specific method. And when I look at this, I can see straight away that almost all of the time for this particular transaction was spent in errors.cfc. And if I click on the method call here, what will happen is FusionReactor instantly decompiles that code. And you can also provide FusionReactor with access to the directory where your repository where your code is stored. And if you provide it with access to the repository, then it will actually bring your code up. In this particular case, this is also the code, but this has been decompiled. So I can see here that what I'm actually doing is I'm doing a dump. I'm doing a recursive call through a number of directories, and I'm actually doing a CF dump in this particular case. And that's actually what's taking all the time. So it's not the it's not my page itself which has got the problem, but the fact that this page had thrown an error, and as I called out into my error CFC, which then called out to this dump.cfc, that's actually what's taking all the time. So the only way that we can, or not the only way, but one way that we can see that is through a profile. And if I just show you similar sort of thing here in the on-premise UI, if I go into the profiler, and take a look at the profile history, I've got 3 transactions here, and this is a different server, so that's why we don't see the profiles that we were just looking at. But just to give you an idea of the capability, here I've got JSP, little JSP program. This one ran for 72 seconds. And again, I can see the whole profile here. And looking at this, whole profile, I can see that I spent 47% of my time in a close, so in a file close. I spent 45% of my time in a file open. So this was opening a file. I can see that from the open method here. And then I spent just 5.8% of my time in a write. And if I click again on that particular file, again, FusionReactor will decompile it. You can see that's instantaneous. And looking at this, I can see I've got an iterator here, which is an iterator that's 100,000. And what I'm actually doing is I'm iterating 100,000 times. I'm opening a file, I'm writing to that file that you can see here, and then I'm closing that file essentially inside a loop. So don't try this one at home, boys and girls. I only wrote this for demonstration purposes, but you can see quite clearly, after looking at the code and then looking at the profile, this is why I spend most of my time in the open and the close. So yeah, that's very, very powerful using that profiling capability. And just in case anybody's interested, very often profilers are, they've got quite a high impact. Not so in our case. So this is a so-called sampling profiler. And I can see here I've got 290 samples. And from those 290 samples, each sample takes about a millisecond. So the total time for this whole profile will be sub 300 milliseconds. And for a transaction which took over 72 seconds, that's absolutely fine. And what we know is that usually profiles, with as few as 5 profiles, they can still be very, very effective at pinpointing performance problems. So let's jump back into here. So another thing that we mentioned before was this ability to do distributed tracing. So if I go back and take a look at the slowest transactions, I can see I've also got this buy now transaction. Actually, let's change that back. This one ran, it was still what we determined as being slow, but it was just around about a second for the majority of these transactions. So much faster than our products.cfm. But let's take a look at this one. And if I drill into this one, I can see when I look into the transaction, I don't really get very much information at this point. I can see that I was doing the CF HTTP post, but this actually only ran for 519 milliseconds. Now the whole thing ran for 995 milliseconds. So what was this doing? And we can find that out now by analyzing the distributed trace. And in this case, if I click on the trace ID, then FusionReactor comes up, and what it's showing me now is, I'll just bring that down a little bit so you can see it better. This is a complete end-to-end trace, and what we can see, sort of the lines going across here, these are what we call spans. And I can see, when I scroll down here, this was my CFM page, this buynow.cfm. I then had an HTTP post, that called out to this order processor, which is actually written in Java. This then called out to my order controller to generate the invoice. I've got a number of database queries here. And then finally, this called out to Kafka, so the message bus. And from Kafka, that actually called out to the shipping processor. And in the case of the shipping processor, this is actually written in Node.js. So this is not cold fusion at all, but I'm still able to instrument and measure that. And this sort of gives us the complete picture of the whole transaction. And if I open one of these, you'll also see that I've got the logs for this span. And when I click on the log link, then this is actually connecting that particular transaction to all the logs for that specific span. So I can see that here. I can drill into the logs, and you'll see I've also got a link back. So if I click on the trace link, now I'm back inside the actual transaction itself. And if I close that one and look back into this, you'll also see what we make available is what we call the node graph. And the node graph, this gives us sort of a graph visualization of the whole transaction. So I can see that I started in Cold Fusion. I then got a call out. I've got this HTTP post call. I called out into my order processor. The order processor did a bunch of database work, so I can see the selects, the various inserts. I can see exactly how much time was spent in each span within that. And then finally, this called out to Kafka. I can see that here. And from Kafka, I went to my order processor, then to my shipping processor, which is actually written in Node. So that's the sort of the end of that. And just zooming out, I can get a really nice graphical representation of that whole transaction. So this is capability that we've now got available with FusionReactor 9, and we're going to be building on this more and more. But the cool thing is that visualization really helps you to pinpoint exactly where in the whole transaction you've got the performance bottleneck. Okay, so that's distributed tracing. What we can also do, another way to look for potential performance issues, if I go back to my on-premise UI, and this is also available in the cloud UI as well. This is our thread visualizer, or thread profiler, and I'm just filtering here based on a name. But what this enables you to do is very quickly, and you'll see this is updating in real time. This is showing all the threads which are currently executing on your instance. And I can see here whether I've got any thread contention. And I can also see the state. So I can see whether a state is blocked or a thread is, whether a thread is blocked or whether the thread is actually executing as I expect it to. And I can also from here profile specific threads, or I can click on the stack trace icon and that will instantly perform a stack trace, which is very, very useful capability. And from here, I can then also, you can see the classes and the methods are all clickable. And if I click on one of those, FusionReactor will instantly decompile it. And you can see down at the bottom, I've got the stack frames, and I can traverse up and down the stack. And you'll see that's updating instantly. So very, very quick. The idea here is that if you're experiencing an issue and you've got something like you're analyzing a thread or analyzing some transaction, that you can very, very quickly get inside the code. That's the idea here. So another area for performance issues is in the area of databases. And if I go back into the cloud, I can see here in the cloud UI that we're automatically sending telemetry from each database that we've got that we're currently using, and we're sending that up to the cloud. And I can see here all the various different databases that I've been using. So if I don't know, take the Spring shop, I can just drill into that one, and then it will just show me the Spring store. And of course, I can go back in time and take a look at that and analyze it. What we've also got, if I jump back into here, into the JDBC view, I can also see a complete history of all the JDBC transactions that have been processed. I can also see things like the longest transactions or the slowest transactions, the longest transactions, the longest transactions across all time. So looking through here, I can see all the details of all the SQL statements which have been executed. So this gives me a really good sort of insight into exactly what I was doing. And if I drill into one of these, for example, yeah, let's just take this one. I can see the complete URL that was executed. This was actually a Postgres call. And if I look into the JDBC tab here, I can see exactly how much time was spent performing these transactions. I can see the database time and the result time, and whether any rows were returned. So you can see some of these actually did return row results. Some of them didn't, but the insight that you've got here is really very, very useful. And we can see, of course, exactly which queries ran. So let's take a look at how we can address, that was some aspects related to performance. Now let's take a look at memory. And with FusionReactor, you can basically get a very nice overview of all the different memory spaces which you've got available in Java. And you can see this is in the on-premise view here, this is live, but I can also go back and look at this across the last hour, or across the last day, or across the last week. Now, one thing which is important to mention with the on-premise UI is that the information, the telemetry that you're seeing in this view, this is all being stored in memory. Now, we obviously compress that data so that the memory footprint isn't that high. It's probably somewhere in total between about 60 to 80 megabytes in total for the week. But the reason why we store this in memory is obviously for speed. At the same time, we're also storing all the metrics, all the telemetry that's been captured. We're storing that in log files as well, and those log files are stored locally. And if we go back into the cloud UI, and then I take one of these servers, I can also see, if I go into here, and then we've got various different views to look at this data. Again, this is coming out, this is actually live, but I can also, look at the telemetry across the last hour, just in the same way that we were able to do that with the on-premise UI. I can also see for transactions how much memory is being used. So if I take a transaction here and I look at requests by memory, then I can see this top transaction was generate.jsp, and this particular transaction used almost 7 gigabytes worth of memory. And if I drill into that, I know the reason for that is actually because this is actually building a database. So this ran for almost 42 seconds. But again, I can see here I've got various create table commands, and then I was doing a bunch of a ton of inserts on this database, and this is actually what used all the memory. So we've got that same capability as well for JDBC requests. So if I look into here and then I look at the transactions by memory, I've also got the same information. So I can see for each individual SQL statements here, these were all the larger ones, but I can see how much memory was allocated. And this could also be very, very useful that you might have a transaction that actually it used a lot of memory, but when you drill into it, the execution time was actually pretty quick. So this run for it had a total time of 119 milliseconds, and 84 milliseconds was spent actually in the database, but it used a lot of, allocated a lot of memory into the heap. And that can be very useful to know if you're looking for some sort of memory anomaly. And what we've also got as a tool available for analyzing potential memory issues is the heap histogram, or the what we call the heap profiler. And if I set the refresh rate here to 1 second, you can actually see the classes changing and updating as we're sampling the heap. So this is actually showing every single class which was instantiated on the heap. It's showing the number of objects which are stored as part of that class, or which are managed as part of that class, which have been created, as well as the amount of heap allocated for each class in bytes. And some of you may be familiar with this particular view if you've used JVisualVM or JProfiler. Those tools also have something similar, but the difference is that I can run our profiling tool actually in my production environment. With the other tools, because of the way that they're built and the process they're actually doing class profiling to get this information, it's just not really, it makes them unusable in a production environment because the performance hit is too high. But again, this is sampling, so you can see it's running very happily in real time. The whole performance hit of running FusionReactor in your production environment is around about 1%. So that's very low, especially compared to other monitors. It's very, very low. And we've put a lot of effort, a lot of focus into developing this so that it's very, very quick. So what you would do here, if you were looking for, let's say you've got a memory leak, what you would do is you would take a snapshot. And what I did earlier today, I took a baseline snapshot just basically as I brought my application up. And then what we can do is we can diff those 2 points in time. So again, this is basically, you've got 2 points in time on the heap where we've took a complete snapshot of what was happening on the heap. And again, I can see here every single class which was instantiated, again, with how many objects, and I can see what the delta is in terms of objects and in terms of actual heap size. So sort of spotting memory anomalies, it's not an exact science, but we've provided a number of different tools and capabilities within Reactor, basically so that you know, we can assist you to get as much information as possible. So next thing we're going to take a look at is what happens if you've got an actual issue and you're trying to address a problem. So I've got a little program here. This is basically divide by 0. So what it's doing in this case is, if I run this, it generates a random number, and you can see now it's 2, before it was 1, now it's 2 again, now it's 3, and eventually there you go. So now I've generated divide by 0. You can see y was this random range between 0 and 3. And if I go into FusionReactor here, I can see, you know, I got a number of transactions were run. And if I go into my error history, I can see this was the, this is basically what just ran. And I mentioned earlier, FusionReactor's got a number of capabilities to help you to pinpoint issues. The first one that we're going to look at is this event snapshot. And the event snapshot is what we call sort of automatic error detection. And in this particular case, without doing anything, FusionReactor's detected, we had a divide by 0 here. It's telling us that here that an error has occurred. It's divide by 0. It's highlighted the line in the code where the divide by 0 took place. And you can see in this particular example here, like I mentioned before, I've pointed FusionReactor at my source code repository, and that's actually it's gone and got the code and it's rendered it in this particular case. And I can also see the scope variables. So if you can see that down here, I've got y is equal to 0. So it's actually showing me what the variables are. And of course, I've got all the scope variables here. So I've got all the CGI variables. I've got essentially all the variables, all the scope variables that are available. I can see them. So what this is doing is essentially it's giving us the full context of this particular error, and it does all this automatically. So I didn't need to configure anything else. FusionReactor just picked it up. And if I click on the error details, let's take this a step further now. So I can see this is running in CF 2018. I've got my divide by 0 code. If I click on the run page, if I hadn't have given it my code, told it where my repo is, it would decompile the CF, and you'd see the decompiled Java here. But in this case, it's showing me my code, and I can actually set a breakpoint here. So just by clicking on that, I've now set a breakpoint. I can see inside the debugger, this is the breakpoint that I've got here. So we can actually edit that. I can see that was the source file name. This was the line. I'm going to fire this breakpoint one time, and I'm going to pause it for 60 seconds when this breakpoint fires. And if I run that again now, you'll see that tab is spinning. And if I go back into FusionReactor, you can see it's indicating we've got this little bug at the top of the page, but this is actually, I'm inside that page now. So I can see this is my thread. So I've intercepted that thread and I've got a timer on that thread. And if I click on the debug icon here, I'm now inside a debugger, inside FusionReactor, inside production. So I'm actually debugging this now live. I can see I've got all my stack frames down the left-hand side. I've got all my variable scope. Again, I can see the code is highlighted it at the line that the error occurred. I've got a watch set up here. So I can see that y is equal to 2. So this is what was generated this time. So let's change that. I'm going to change that to 0. And when I do that, I can see that the watch changes on the right-hand side. And if I now resume that, then what we would expect is that that gets resumed, and lo and behold, I get the divide by 0. So I was just able to debug that in production and actually change a variable during runtime. And obviously, this is a capability. This is unique to FusionReactor. It's it's not going to be something that you would use every day, but it could be something that having that capability available to you can really make the difference of finding that corner case issue. If you imagine probably the times that you said, oh, this defect, it only ever occurs in production, I can't reproduce it, then having that capability would allow you to, you don't need to reproduce it, because you're in your production environment, and you're able to set a breakpoint, and you can also set what we call a trace point, so you can actually have FusionReactor mail you out the context of a point inside your code, together with all the variable scope. So just like similar to what you've got with CF dump, you can actually set a what we call a trace point in this case inside your code, and have FusionReactor mail you the whole context. So that's that. I'm going to show you the logs, the log capability. So we've looked at performance, we've looked at memory, we looked at the error debugger. Getting the most out of logs, you can now use FusionReactor to capture any log files. We can filter log content. We can visualize the logs. We have built very powerful dashboards, and we can also, as we saw before, we can link logs back to transactional information to enable you to diagnose issues a lot quicker. And if I jump back into here, and then I'm going to go back into, let me just click on my dashboards here. You can see in the dashboards view in the cloud, we've got a number of different log dashboards. I'm just going to show you a couple of these. First one's the log errors. So this is actually capturing, automatically it's capturing error text. So if I've got error warning info or exception, it's capturing that, and I can see the actual graph. These are the error log rates that are coming through. So this is showing the last hour. If I update that, say show me the last 3 hours, it will change. So you could see I brought one of my servers online, this Tomcat server, and that started causing problems around 5:20. But this is just ingesting logs. It's very, very quick. Also, if I change that, say, okay, let me look at transactions which were just info related transactions, then the graph changes and I instantly get each log transaction, which was basically an info. So that's very useful. Discard that. Going into here, another one that's quite useful as well is the resources and logs. So what this is doing, let's just bring that back down to the last hour. What this is doing is it's looking at log throughput rates compared to CPU utilization, compared to memory utilization and JVM memory. And then it's correlating all this information together. So again, you know, I can search for specific things here if I just wanted to look for errors and look for errors in relation to those different resources. I can do that. I can also break this down and say, okay, I just want to look for specific jobs. So if I just wanted to look for, I don't know, my CF storefront, I could do that. So I could, we've got a lot of options here for actually breaking down the data. I can also see things like, if I go back in my log dashboard here, log status is an interesting one. So this is giving me a heat map of the various different, in this case, various different instances together with the logs which are being generated. And if I go back and look at this, let's look at it over the last 3 hours, then I can see I've got different instances which came up. I got this order processor, my CF 2018, my CF storefront, and my Tomcat server. And I can see from the heat map that the Tomcat server, this was generating the most issues inside my logs. So that's also quite interesting. Got a few more minutes left. Let's just take a look at some of the other dashboards that we've got available in FusionReactor. So let's take a look at the request performance. So this is basically, this is showing the top 20 requests by throughput. Again, I can restrict these. So if I said, okay, I just want to look at my, let's just take a look at the store here, then hopefully that should, okay, so that's changed things. And I'm just looking at the transactions that have been going through the store. And I can also correlate this to traces. You can see that this machine actually, that this did have some downtime this afternoon because we stopped sending transactions. And what I can also do here is if I just click on one of the points in that graph, I can correlate this to events, or I can add a notation. So if I added a notation and say, you know, I can say whatever, server went down, and I can add a tag to this. So a tag might be, you know, a server cycle tag or some tag which is specific to this event, and then save it. And then you can see this is highlighted on the graph. And this basically, this will, this event or this tag will get highlighted across all the graphs. So it enables you to sort of create events, tag them, annotate them, and have that available right across the whole platform. What else have we got? We looked at the database utilization before. We've also got things like the oh yeah, service changes. Very, very useful. So this is actually showing me instance deploys and instance shutdowns across my application. This is looking at the last 24 hours. But you know, if I extend that, let's take a look at the last 30 days, and you can see this is really useful information because this is going to enable you to correlate certain events And what we'll be doing is we'll be able to, in the future, we'll be able to link these service change events to potential issues or anomalies which have been coming up. So, and we can go back, we can go back even longer, up to 90 days. And we're going to be extending this as well. So in the very near future, we're actually going to be offering up to 180 days worth of historical data. So those are some of the FusionReactor dashboards, some of the stuff which is coming up very, very soon. Somebody asked before, Jacob asked, what about nginx? So here you go, here's an nginx dashboard that we put together. This is showing the last 5 minutes. Let's take a look at the last hour. We've also got, let me go back into my dashboards view, node exporter. So this is some of the capabilities which are coming up sort of in the very near future now. If I take one of my other jobs and take a look at this, let's just take a look across the last 3 hours. So this is basically, this is a node exporter here. So I'm actually seeing hardware, and if you scroll down, you can see all the different telemetry that we were able to render here. I've got file system telemetry. I've got disk storage, so I can see disk IO ops, how data's being written to disk, wait times on the disk. I can also see things like network traffic. So under here, I can see exactly how much traffic's been going through, whether I had any errors. And again, the whole point of this is being able to correlate data, not just from an application, but basically right across the whole infrastructure. What else have we got? So that was Node. We looked at the databases earlier. Some of the new stuff that's coming. So real quick, I know we've only got a couple of minutes left now. Getting the most out of logs. So what's coming up very soon? Infrastructure monitoring. I've just shown that with nginx and Node, but we're also going to be supporting Kubernetes, Kafka, AWS is going to be coming. The idea is to provide lots and lots of different dashboards which are rendered automatically when we detect specific technology. We can also instrument now other languages, so not just Cold Fusion or Java, but things like .NET, Node, Python, C++. We're also going to be providing synthetic monitoring to give you sort of an outside-in picture, and we're also working on machine learning. And if I just switch back here, I can actually show you one of the things that we've been doing. So here under the CPU machine learning graph, you can see this is CPU data here, and we're analyzing that to come up with an anomaly score, and then based on that score, we're detecting whether we've got an actual anomaly flag. And if I open this up, that's looking at 12 hours. So this is looking at 24 hours. So you can see it's actually, because it's got more data available, it's actually generated more anomalies. And if I go run to 2 days, yeah, it didn't detect any more down here, but it's actually, all these points on the anomaly flag, these are all potential issues that it's derived by analyzing the data. In this case, it's just sort of CPU data, but the interesting thing here is when we take different metrics and combine those metrics, sort of joining the dots, the anomaly dots based on the machine learning algorithm, to then say, ooh, you had high transaction throughput that resulted in an issue with memory, which was actually linked to another issue, which was maybe in the database. but it's the ability of the machine learning algorithm to essentially correlate everything together. So that's some of the things that's coming. That's sort of the end now. Q&A, I've got a question from Jacob. He was asking about nginx, so I demonstrated that. There's a question from Jim. David, do you have a list of the number of configs you have available out of the box for the different logs that you're able to pass? All the Cold Fusion logs, the FusionReactor logs, are all available automatically. So if you've installed FusionReactor 9 or above, those will all be available. And you can also configure FusionReactor very easily, actually, to ingest any log file. I didn't show the presentation slide for that, but it's very straightforward. We go over it in the documentation, and also very powerful. So also, is it on the logs, or does FusionReactor also have any agents that may be checking application messaging or events? We do have I didn't demonstrate that actually, but we've got a very powerful alerting engine that will also generate alerts based on logs, but also on any other metric. So let me just see, we've got one here, error count threshold. So if I bring that one up, this is just looking for errors. So this is looking for on this app error count metric, and you can see I'd set the threshold at 6, but FusionReactor will basically show exactly how many errors were occurring. So whichever metric it was, it just presents it graphically so that you can see what the threshold would be and how that's affected. So any other questions? No, I think we're good. I know we're at the end now. Yeah, that was pretty much the last slide, the summary slide. FusionReactor lets you know when, where, and why issues occur. It's very low overhead, gives you full observability, lots of different languages, plus logs, plus infrastructure. You can use it in your development environment as well as the cloud, as well as your production environment. It's dead easy to install. There's an automatic installer. We've got a 14-day trial. Billing wise, you can do reservations, so you can say, okay, I need this many seats, or we also do on-demand licensing, which is just 13 cents per hour if you do the on-demand licensing, and the costs start at $19 for a developer, up to $99 per server per month. Whew, finished. Any other questions? So anything else? Maybe 6% of survey respondents. I missed that one before. POD and development, really tech. Yeah, it is sort of a point of view of development. I mean, FusionReactor is a very techie monitor, but we again, you know, if an error occurs, it's the developers who've got to fix it. So, you know, by providing information to the developers, the information that they need, then, you know, we're going to speed up the time required to identify and to fix an issue. Is there an API into FusionReactor so we can bring data into our own screens? There is an API into FusionReactor. It's called Frappy. So if you search in the docs for Frappy, you should find that. Or if you get any problems, please send an email into support. Thanks for the presentation. Very informative, exciting new stuff. Great. Okay, so Jim asked, how is the pricing determined? So if it's on demand, it's basically the license is you need one license per physical or virtual host, or if you're running in cloud, it's actually you can have up to 4 Docker containers per license. So that really sorts of makes it very, very cost effective. And if you're running the on demand, then basically it just if you bring FusionReactor up and it's licensed, it will start ingesting data, and then it will actually bill you for every full or partial hour that you use FusionReactor. And like I said, it's 13 cents an hour. So if you used it for an hour and a half, it's going to cost you 26 cents. And hopefully, yeah, Jim, I was able to answer that question. So that's it. Thanks, everybody. Yeah, thanks for joining. And if you've got any questions, you can email us at sales@fusion-reactor.com. Obviously, there's the website. We've got a YouTube channel. And yeah, that's it. Thank you very much. And have a great day and a happy Thanksgiving to everybody when that comes up.